What's up, guys? Let's take a look at another CodeWars exercise. This one's called Rail Fence Cipher, which is not made up for the problem. It's a classic idea. You take a message and write it diagonally down, up, and then you collect all the letters on the top row. You collect all the letters in the middle row, or however many middle rows there are, and then you collect all the letters from the bottom row, resulting in a nice scramble. Starting with "we are discovered, flee at once," you could end with a pretty jumbled message. Well, it actually still starts with "we," but that's just bad luck. And then the person receiving it wouldn't know how to read this unless they knew the system. So we're going to get two things: the message and the number of rails, because it doesn't have to be 3. It could be going down more before it comes back, or it could be just to zigzag quickly. Then the hard part is we also have to go the other way, where we get a scrambled message and we have to unscramble based on the same system. I'm going to do the encode first because I think it's easier, and also because the way I'm going to do it, the decode uses that as part of its system. So I'm going to start by just numbering these rows or rails, and we're going to go 0, 1, 2 just like anything else, a little zero-based index. I'm going to do it in 2 steps. One is like a chunk, and then the next is stretching it out however many we need. So a cycle down, up, and then however many cycles we need for this message. It could be short or long. So a single cycle is range in, that's just going through them all once. And then on the way up, you don't need to do as many, because we don't need to cover the bottom again, we just did it, and we don't need to cover the top because we're going to be at the beginning of the next cycle covering the top. So it's going to go from n minus 2 to 0, not including, and moving backwards. Now you can't add ranges, so I'm going to put lists around it to make them combinable, extendable. And then I'm going to print cycle to show what I'm talking about as an example. There's also a way to make sure I didn't do it wrong. I didn't do any typos or whatever. Oh, this is telling us we have to have something in here. I'll just put an ellipsis until we fill it in a little bit later. This is 0, 1, 2, 1, 0, 1, 2, 3, 2, 1. That's a cycle, right? However far we go down, we go back up. And then we need to do a bunch of cycles to get through the whole message. So I'm going to call that rails because that's what the theme of the problem is. You can imagine actually putting this on a fence somewhere physically in front of you. So rails is cycle times however many we have. So however many we have is like the length of the string divided by a cycle. If it's twice a cycle, we need 2 of them, right? So I'm going to go len of string over len of cycle, and then just in case, I think we should throw in a +1 because that integer division might round us down. You never know. I don't know. We'll see what happens. And I think I need some parentheses right here. Again, I'll print rails to A, show what's going on, and B, check for errors. So this is like 0, 1, 2, 1, 0, 0, 1, 2. Seems about right. I think we can move on. So now the deal is we're going to take these rails and attach them to the letters. This is using the Python zip function, which takes one thing, another thing, and zips them up. And then we can sort them by the numbers. We couldn't sort the letters. They don't know where they're going. But if we sort them by the numbers, then the letters will hitch a ride onto the right place, because what are we doing with this? As I said originally, we are collecting all the top row, which is like the zeros, and we're collecting the middle row, which is the ones, and they're in that order, so that'll be great. So I'm going to say something. I'm going to call it chars because it's characters. We don't guarantee a letter for everyone. It could be a space or something else. So chars equals char for, and then there's going to be 2 things. We're going to have the rail and the char, but we're only taking the char. The rail is just the ride to the spot, but it doesn't actually show up in the result. And so then we're going to go zip of rails and string, but we're going to sort that whole thing with a key. I think I need the key because I tried this a minute ago where I think the way it works, and I'll have to look this up, is with a tuple they just use the first one and then they use the second one as a tiebreaker. But we don't want to put these in alphabetical order in each row. Like, that's not what it's about. We want to use the tiebreaker of where they were before the sort, which I think is what happens if you just give it one thing that's not a tuple. I'm not clear on that, but it worked when I tried it a minute ago, so let's do it. Key equals lambda x x0, which is just the first thing, which is just the rails. Okay, so then I need parentheses, and then I need another one because I'm going to put parentheses around the whole thing. So I could print chars. I think I have to put a star here because I made it a generator, and then I'll show you if oh, typo. And then, hey, that's pretty good. So now we can join and then return. So that's going to be great. That's the encode. We passed those tests. I love it. This is the easy part, and then the decode is a bit harder because you can't just line up some numbers and go. You have to, well, at least the way I'm doing it, what I'm doing is I'm going to start with a range. Just go 0, 1, 2, 3 all the way to the length of the string, and then encode that so that they're all rearranged, and then attach letters and then sort them. And so the sort is doing the same job, but it's not doing the same thing. The sort in this encode was doing like 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, because of the rails. And the sort in this one is just 0, 1, 2, 3, 4, a single number all the way down, which will correspond to the way the character should have been before they got this process. Now, the only problem with that is I would love to just call the encode. Like, I would love to just call the thing I've just made as part of the decode, but I set it up to give you characters, and we can't do characters because we need them to be numbers, and it would mess up. Like I said, I tried this a minute ago, and it would mess up when we give it double-digit numbers. If we give it an 11 and it tries to sort, and the ones are separate, and it doesn't work. So I'm going to do something that's not very good, but I'm going to copy paste. I'm going to take these lines and use them again, change a little bit, and then finish off the function. Obviously, it'd be nice to reuse them. Maybe I could make a third function that does this, common job that's common to both of them, and just turn it into a string at the last second in this guy, but this will work for now. So these two are exactly the same. The cycle and rails are the same because we still know how many rails there are, even though we're going backwards through them. Okay, and then this part is the thing that's going to be different. We're going to call it, indices. This is like the numbers. This is like the range thing. So I'm going to call it indices, and then I'm going to say I for rail and I, and then instead of the string, it's just some numbers. It's just range of the len of string. And maybe we need to do a +1 or -1. I don't know. I think it's fine because zip doesn't matter if there's some left over. If you have two things and one of them is a bit longer, zip just zips them as far as it can, and then it stops. It doesn't care. Whatever. So this is the same idea as we did a minute ago, but it's just zipping a length of numbers. And if I print that, it's not going to look good. It's just going to look like some numbers in a weird order, but we'll see what is happening. So like this is what was happening to the letters in the encode function. The 0th was the first thing, and the 6th was the next thing, and the 12th was the next thing. Okay, so if we take this and we attach the jumbled letters to this, and then we sort them by these indices, then the jumbled ones will hitch a ride back to the position where they should have been before being encoded. And I'm sure there are better ways to do this. I'm sure you can just algebraically like figure out how many are in the top row and how many are in the middle row. But I thought since I already just did the encode thing, I could use it and then add a bit more. So then we're going to say, we're going to have another thing called chars, because eventually we're going to have characters, right? Chars equals char for I char, because we're going to have them hitch a ride onto the numbers. And the numbers, I just called them I because it's an index. It started out as a range, even though it's not a range anymore. This has exactly 1, 0, 1, 1, 1, 2, etc. Okay, and we're going to zip the indices and the string, and then we're going to sort it around that whole thing with maybe not a parentheses yet. And then the same as I did a minute ago. This is a bit ugly to do the key like this, but I think we have to, because otherwise it'll use the string as a tiebreaker and it'll put some in alphabetical order when that's not what we want. Okay, so I think that's right. Let me test it out. Print star chars, and nope. What did I do? Oh, I need parentheses on here, and then maybe another one over here. Beautiful. See, we're getting somewhere. And then space it out to look nice. And then we're going to return join of chars. Hey, look at that. I love it. I'm going to test them out real quick. We passed the test. So this was really fun, and it's the first time that I've done a level 3 in one of these videos, so it was a bit more complicated. But I think the way that I did it is something you can follow, at least if I did an okay job of explaining. So we take numbers, we take letters, and then we sort them by the numbers, allowing the letters to hitch a ride in the spot they need to go. This works both ways as long as we set it up. The decode took longer to set up. I mean, 2 lines is not that much. And they follow the same pattern. Let's go to the solutions from other people to see what they came up with. Okay. This is lovely, because this is what I was talking about a minute ago. I actually opened this tab, but I hadn't looked, so it's just a coincidence that great minds think alike. So this person is doing what I said a minute ago, where the encode is just a join, because you have all the work outsourced into this common function, this common work that's in both of the things, right? Like he called it fencer, which makes sense because it's the fence thing. The fencer is involved in both of these, just like in mine, these 3 lines are involved in both of the functions. And then you can make it abstract so that we're not getting lost in the details. In mine, I was getting lost in the fact that this one was given characters, so I couldn't use it here, blah, blah, blah. Whatever, it's fine, but when I look at that, I go, nice, good job. You did the thing that I thought of, but I didn't do it myself. Okay, let's see another one. We got a nice little, similar idea, which is where you are taking the common element, putting it in a third function. Maybe that's what they intended. Maybe when this person made the kata, they decided, you know what, my test is whether the user can figure out that there's really a third thing involved and add their own function. IterTools has a thing called cycle, which, hey, maybe I should have used that, but I didn't know about it, so great. This other one, okay. So a minute ago I said zip will just ignore if it has some gas left over in one of the sequences when the other one runs out. This one imported a zip longest, which is interesting. I think the reason is, and I'm just looking at this quickly, But when I Googled earlier, I Googled like railfence Cipher to see what was out there. And a lot of people were talking about padding the string to make it just a little bit longer to fit into a cycle. So if you have zip longest, you don't need to pad it because it'll just keep going based on the sequence, and it'll just, I think you can specify a default on zip longest or something to fill in what's not matched on the other side, you know. But these are nice. I really like these solutions because, like I said, it's a hard problem. It's a level 3, but it's not like 50 lines of code. It's just, you know, 7 or 8 for each function, and maybe less if you're good. I think this one's a bit longer because he's just doing a lot of little indenting stuff, which could have been wrapped up in an itertools thing or a zip thing, but it's just traversing down the line. Totally reasonable. And I like this one. I think it was fun, and it's the first time I've done a 3 as one of these videos, which should let you guys know that they're doable. You know, they're not the hardest thing in the world. They're just maybe a 2-parter where you have to like do this and then use it for the next. Stuff like that is sometimes the most fun. Thanks.